everyone, and welcome back to Bitcoin Faculty. I'm excited to announce that we've covered all our basics in Python on learnpython.org. And then from today, we're taking the next step in our journey, which is working towards certification in the fundamentals of Python. To achieve this, from now on, we're going to be using the Saylor Academy website. And the best part is that certification is completely free. I do suspect that a lot of what we're going to cover in the introduction to Python will actually revisit topics we've already explored. However, it will build upon what we've learned so far, and it also includes exercises to help us practice our code. Revision is key because repetition helps us remember everything we've learned. So, without wasting any more time, let's dive into our first unit and take our first step to getting certified. So this is the Saylor.org Academy website, and I'll be putting a link to that in the video description. I'd just like to show you how to navigate the website to get to where we need to go. So we are going all the way down to computer science, and then we're going to introduction to Python. Then, as you will see here, there are basically 10 units. And just to show you here, we have the exam, which we will take at the end. And that exam, we need to get a grade of 70% or higher to pass. So that is our goal. So let's head over to Unit 1. This unit will introduce you to the Python 3 programming language and cover how to use a platform-independent web-based programming environment to begin writing basic Python scripts. We will introduce basic Python data types, the assignment operator, and how to output data to the screen. So, for those of us that have already done my previous videos on the basics of Python, we were over here on learnpython.org, and we've basically done all of these basics here. So it's going to be revision for us and building on the knowledge that we already know. But also just a reminder why Python 3 is important is because that is what we're going to be utilizing for purposes of programming Bitcoin and our strategy that we are implementing on this channel. So first of all, we have a video over here. I will play that now, and it basically just explains what Python is. So let's head over and play it.
Okay, let's start digging into Python here. Now, before we go anywhere, we probably should answer one question, which is, what is Python? And if we're going to ask this question, we should, of course, answer it with a quote from Wikipedia. So Python is an interpreted high-level general-purpose programming language created by Guido and first released in 1991. Python's, and well, you can read the rest to yourself from there. And let's try and translate that into a bit of English here and what we can actually do with Python. So what is Python? Well, as it turns out, Python is an extremely flexible programming language that you can really do any type of development that you might want, be it functional, procedural, or object-oriented, and create really any type of application that you might want, including things like web development, machine learning, etc. Python is also designed to be human readable. So that way, if you're not real in tune with a lot of different like C++ syntax and things like pointers and so forth, fortunately, you don't have to worry about that when it comes to Python. It's designed to be, well, at least quasi-close to English. Now, why use it? Well, it's a great starter language. Now, what's nice about Python is there isn't necessarily a lot of huge syntax to learn, that you are going to notice, again, there aren't a whole lot of funky little characters and things like that. And it's also going to help teach you some really good best practices that you'll want to use with any programming language that you might be programming with. But it's also a great advanced programming language as well, that again, Python is flexible, so that Python can grow with you. So as you grow in your career, as you start digging deeper into, say, machine learning, Python can come along with you for the ride. You don't necessarily need to go out and learn another language. Finally, Python has a fantastic community that if you're thinking, hey, I want to do fill in the blank, chances are somebody has been nice enough to create a package that you could go ahead and use to perform said task. So the last question then is, what can I build with Python? And the answer is pretty much anything. So you could do machine learning models, you could do AI projects, web applications, which is personally what I find myself using Python most frequently for, automation utilities, and really pretty much anything at all. And again, that's the great power of Python, its flexibility and its ability to grow with you. So now that you know a little bit about Python, we'll close off here, and then in the next video, we'll talk a bit about what you're going to need to start writing your Python code.
All right, so I'm now going to mark it. Okay, it's already marked as completed. Then we also need to, so I've done these top two. We also are going to access the IDE. So basically, it's a web-based IDE. So unlike some software that you use to code, you have to actually download it onto your computer. In this case, there's no installation required. This is where we're going to be programming and writing and practicing our code in Python. We will be using this IDE throughout the course. On the page, you will see two windows arranged side by side in columns. In this unit, we will focus on the rightmost window. The window has a command line prompt, which is indicated by the greater than sign. We can type basic Python commands using this command line prompt. As we progress through the course, we will start to use the middle and left windows. It also says here you will need to have JavaScript enabled in your browser. So this is the basically Repl.it.com. I've already created my account. It's quite simple. Just put that you're a beginner and it will open up all of this for you automatically. However, I did encounter a problem. So that is why these two are marked as complete. So I had to stop the recording because this example here, where we were trying to type in the right hand side here, you see the greater than sign, I can't type anything. So anyway, I searched what the problem is, and basically there was someone here who was also doing the Saylor Academy course. And what's happened is they've removed that functionality. So we're going to click here, but you know what I'll do? I'll put the link in the description. We're going to have to be able to enter code into the console, which is this right window here. You see it says console. We need to use the Python with prybar template. And then we're going to click on use the template. So I'm going to click on it. We're going to say use template. We're going to say use template. And that is it. results of your code. Yes, I know that. Yeah, then click Run on the right-hand side here. And then it's going to basically do an update, and then we'll be able to type now in the console. So that is something that is actually not here. I see this was last updated in 2020, so it's not included there, but now you'll at least know how to enter stuff in the console. So I'll put that link in the video. So now if we enter 1, we get 1. So we're not working in this window yet. So for unit 1.3, we are looking at data types, integers, and floats. So we learned about, on learnpython.org, we've learned about strings and then numbers, and numbers can either be integers or float numbers. Programming languages, sorry, there's a pop-up here. I really need to disable these things that irritate me. Okay. Sorry about that. Okay. Programming languages must distinguish between different types of data. Since we want to introduce simple Python computations, it makes sense to discuss numerical data. The goal of this section is to introduce 2 fundamental numerical data types, int and float. The int data type refers to integer data, numbers not containing digits to the right of the decimal point. In other words, whole numbers. So like -10, 0, 357 are integers. The float data type refers to floating point data. These are numbers that contain digits to the right of the decimal point, such as 1.3, -3.14, and so on. So any number that has a decimal, even if it's negative, is a floating point number. And an integer, which is a whole number, can be positive or negative. It can even be 0. So after we complete this section, we should be able to explain the difference between int and float. There are deeper reasons why we might distinguish between these data types. Those have to do with how they are represented within a computer system. Our goal for this section is simply to be able to visually identify integer and floating point numbers. On this page, you will see more examples of int and floats. The int data type refers to integer numerical data. In the rightmost window of the IDE, use your mouse to click. Okay, so we've already solved that problem because it's not going to work unless you use the pry bar, Python with pry bar. See up here at the top. Whoops. Okay, so you see it's working now. So I'm actually going to close that one here. So make sure you're using the Python with pry bar. So basically what they're asking us to do here is to basically mess around with a few different integers. So 2, we can do 100, do 0. Okay. The float data type refers to floating point numerical data. In the rightmost window of the IDE, type the floating point number 2.57 and press enter. You should see the IDE echo the value back to the screen. Okay, so 2.5. Okay. It is of utmost importance that you understand the value 2 is of type int, while 2.0 is of type float. On paper, this might not seem like a big difference, but the decimal point is how a computer tells the difference between these 2 data types. So the way we understand numbers, right? 2 and 2.0 are the same thing, but the computer is going to identify one as an integer and one as a floating number. I'm not calling it a floating point number. So there actually is a difference when you're programming because there's two different types of numbers. So compare and contrast int versus float. Programming languages must distinguish between different types of data. We've done that. So these are some examples we can mess around with. We can already start using pluses and minuses. So we can already do some basic calculations here. So 5 plus 6 gives us 11. We can do 3 minus 1 gives us 2. So the star is multiplication, 4 times 5, 20. Exponents, so 2 to the power of 3 is 8. And then we can do division. We can do integer division. So for example, if we say 4 divided by 2, so that's 1 /, we'll get 2.0. If we want an integer division, in other words, we don't want that decimal place, I presume we could say 2 /, and you see now it gives us an integer and not a floating point answer. And then the modular operator, we've covered that quite a bit previously, and I don't want to actually, our answer is 1, but basically what you do is you say 2 can go into 9 3 times, because we got 2, 4, 6, 8, 4 times. So basically the difference between 9 and 8 is 1. So that's the function or the purpose of the modular operator. And we've already learned how we can use that to identify even numbers and even odd numbers. A type is a set of values and operations that can be performed on those values. 2 of Python's numeric types, integer, okay, and then float. And then we see here arithmetic operator precedence. So when multiple operators are combined in a single expression, the operations are evaluated in order of precedence. So this is going from highest to lowest. So think of BODMAS when you do mathematics. If you have a sum and it's got pluses, minus, timeses, we know that we always do the brackets first, or multiplication, and then plus and minus is always last. So Python already has built within it a certain type, I guess, of operator precedence, where it will automatically for you work on multiplication first and so on. So it follows orders of operations. Syntax are the rules that describe valid combinations of Python symbols. So we've already covered that quite a bit, but basically it's the way we write our code in Python. If you don't do it correctly, like for example, if you use square brackets instead of round brackets, you're going to get errors. If you don't use your indentation, you're going to get a syntax error. So that's what they explain here. So a syntax error occurs when an instruction with invalid syntax is executed. You see here the syntax is wrong, so it's saying invalid syntax. A semantic error occurs when an instruction with invalid semantics is executed. float division by 0? Do they talk about semantics? Semantics is the meaning of a combination of Python symbols. It is the meaning of an instruction, what a particular combination of symbols does when you execute it. Okay, so we are now done with integers and floating point numbers. Now we're going to look at scientific notation for floating point numbers. Another way of typing floating point data is to use scientific notation. For instance, the number 0.0012 can also be entered as 1.2 E-3. So remember, if we go 3 times to the right, so we move our decimal point, 1, 2, 3, that's how we get 1.2 and then the 3 here, and it looks like we use E. So in this example, E-3 means 10 to raised to the minus 3 power. And this value is multiplied by 1.2. Hence, 1.2 is equivalent to 0.0012. Try typing 0.0012 into the IDE and then 1.2 E-3. And we should get the same result. So 0.0, let's refresh. So we just need to click on run there. So 0.0012. Okay, now if we say 1.2 E-3, we should get the same answer. So I hope you guys understand where we get the 3 from. It's because we have to move the decimal 3 places. Okay, and it's E. We use E-3. You should see that Python views both entries as the same value. Scientific notation is very useful when the exponents are very positive or very negative. In data science, exponents in numbers such as negative 5.63 E127 or 2.134589 E-63 would not be uncommon. Rather than writing out numbers of this kind in their full form, scientific notation offers a more compact, readable form for presenting float data. If you need to review scientific notation, watch this video. So it looks like that what I thought was a dash is actually negative. So negative, I suppose, implies that let's test it. Nope. So let's try negative 5.63, and then we have E to the power of 12. So let's see here. So we can see here that positive indicates to the right of the decimal place, to the left, and negative indicates to the right of the decimal points. So in this example where we had negative, then we know that we're actually moving the E 3 places to the left. So 1, 2, 3 places to the left gives us 0,0012. If it's positive, it means actually effectively removing and think of positive as right, removing that decimal point 12 places across to the right. So if there's an E and there's no negative, it means it's positive. We're going to move our decimal point to the right. And if it's negative, it means we're moving our decimal point to the left. So this is a repetition. And you will see a video if you would like to watch that. I'm going to mark this as complete. Okay, variable assignment. So we should be quite comfortable with this. Computers must be able to remember and store data. This can be accomplished by creating a variable to house a given value. The assignment operator equals is used to associate a variable name with a given value. For example, type the command a equals 3.45 in the command line window. This command assigns the value 3.45 to the variable named a. Next, type the command in the command window and hit the enter key. You should see the value contained in the variable a echoed to the screen. This variable will remember the value 3.45 until it is assigned a different value. To see this, type these two commands. So let's have a look at that. So we're going to say a equals 5. Okay. If I enter a, which is our variable, it should give us 5. But we can at any time later in the code change the variable a. Let's change it to 10. And now if I print a, it will print 10. You should see the new value contained in the variable a echoed to the screen. The new value has overwritten the old value. We must be careful, since once an old value has been overwritten, it is no longer remembered. The new value is now what is being remembered. Although we will not discuss arithmetic operations in detail until the next unit, you can at least be equipped with the syntax for basic operations. So plus is just a normal plus sign. Then we have subtraction, which is a minus. Multiplication is a star, and division is a /. And we've already done examples, but that one looks like fun. So just to illustrate, if we say a equals 5, and we say b equals a plus 5, what do you think our answer will be? If I say b, it should give us 10. Okay, because it's taken a, which is 5, and 5 plus 5 is 10. After you read, you should be able to execute simple assignment commands using integer and float values in the command window of the IDE. Try typing some more of the examples from this web page to convince yourself that a variable has been assigned a specific value. So let's go to our resources. We've done that one. Okay, I'm going to read from this point on. In programming, we associate names with values so that we can remember and use them later. For example, here, it remembered A and we were able to use it later on when we created a variable called B. The repeated computation in that algorithm relied on remembering the intermediate sum and the integer to be added to that sum to get the new sum. In expressing the algorithm, we use the names current and sum. In programming, a name that refers to a value in this fashion is called a variable. When we think of values as data stored somewhere in the computer, we can have a mental image such as the one below, for the value 10 stored in the computer and the variable x, which is the name we give to 10. What is most important is to see that there is a binding between x and 10. Whenever the binding in the picture in effect, the value 10 I need to slide across here. Let me try and zoom out. The value 10 will be substituted for the variable x in expressions involving x. The term variable comes from the fact that values that are bound to variables can change throughout computation. Bindings as shown above are created and changed by assignment statements. An assignment statement associates the name to the left of the symbol, equals, with the value denoted by the expression on the right of equal. The binding in the picture is created using an assignment statement of the form x equals 10. So x becomes the variable and 10 becomes the value. We usually read such an assignment statement as 10 is assigned to x, or x is set to 10. If we want to change the value that x refers to, we use another assignment statement to do that. Suppose we execute x equals 25 in the state where x is bound to 10. Then our image becomes as follows. Note that the binding between x and 10 has been broken and a new binding has been established. Let's execute a few assignment statements using the Python interpreter. In the video below, you will see the Python shell displaying equals then or greater to none after the assignment statements. This is unique to the Python shell presented in the video. In most Python programming environments, nothing is displayed after an assignment statement. The difference in behavior stems from version differences between the programming environment used in the video and in the activities, and can be safely ignored. So it looks like the video is no longer there. So I think we should by now be comfortable with variables and values. Let's talk about choosing variable names. Suppose that we use the variables x and y in the place of the variables side and area in the examples above. Now, if we were to compute some other value for the square that depends on the length of the side, such as the perimeter or length of the diagonal, we would have to remember which of x and y referred to the length of the side, because x and y are not as descriptive as side and area. This is important. So this means that you should make your variable names as descriptive as possible. It says that in choosing variable names, we have to keep in mind that programs are read and maintained by human beings, not only executed by machines. I mean, you could also easily forget that what X actually refers to, rather just be more specific. Then notes about syntax. In Python, variable identifiers can contain uppercase and lowercase letters, digits, provided they don't start with a digit, and the special character, underscore. Although it is legal to use uppercase letters in variable identifiers, we typically do not use them by convention. Variable identifiers are also case sensitive. For example, side and side are two different variable identifiers. There is also a collection of words called reserved words, or also known as keywords, in Python that have built-in meanings and therefore cannot be used as variable names. So we will see that in Unit 2.3.1. So just some important things about syntax. So this is when we choose our variable names. So one is our variable name should be descriptive. Two, it seems that the convention or the standard is that we use lowercase letters. Thirdly, numbers are allowed, or digits provided. I don't know if they mean digits, I presume they mean numbers. So you can't start with a digit. And in terms of special characters, like your star, your pluses, your minuses, we only use the underscore. So that's usually to separate words. So for example, we would say my name. Okay, it doesn't have, I haven't defined my name. You can see I use the underscore and it's all lowercase letters. Also keep in mind that variables are case sensitive. So you could have two variables which are basically the same word, but if one starts with a capital letter, it's going to create two different variables. And then lastly, we just need to keep in mind our keywords or our reserved words. So let's look at syntax and semantics errors. Now that we know how to write arithmetic expressions and assignment statements in Python, we can pause and think about what Python does if we write something that the Python interpreter cannot interpret. Python informs us about such problems by giving an error message. Broadly speaking, there are two categories for Python errors. There are syntax errors and semantic errors. Syntax errors occur when we write Python expressions or statements that are not well formed according to Python's syntax. For example, if we attempt to write an assignment statement such as 13 equals age, Python gives a syntax error. So in this case, it should be the other way around. So we always start with the variable and then we assign the value. This is because Python syntax says that for an assignment statement to be well formed, it must contain a variable on the left of the assignment operator, so the assignment operator is equal, and a well-formed expression on the right of the equal sign. Then we have semantic errors. These occur when the Python interpreter cannot evaluate expressions or execute statements because they cannot be associated with a meaning that the interpreter can use. For example, the expression age plus 1 is well formed, but it has a meaning only when age is already bound to a value. If we attempt to evaluate this expression before age is bound to some value by a prior assignment, then Python gives a semantic error. So we would have to make sure in this example that age is already predefined with a number, which is a value. Even though we have used numerical expressions in all of our examples so far, assignments are not confined to numerical types. They could involve expressions built from any defined type. Recall the table that summarizes the basic types in Python. The following video shows execution of assignment statements involving strings. It also introduces some commonly used operators on strings. For more information, see the online documentation. So, I think, I'm not sure who the author of this video is. If you guys want to watch the videos, we're just doing revision in this series, so you can, like I say, head over to Saylor, and if there's something you're not understanding, then go through that. Distinguishing expressions and assignments. So far in the module, we have been careful to keep the distinction between the terms expression and statement because there's a conceptual difference between them, which is sometimes overlooked. Expressions denote values. They are evaluated to yield a value. On the other hand, statements are commands or instructions that change the state of the computer. You can think of state here as some representation of computer memory and the binding of variables and values in the memory. In a state where the variable side is bound to the integer 3 and the variable area is yet unbound, the value of the expression side plus 2 is 5. The assignment statement side equals side plus 2 changes the state so that the value 5 is bound to side in the new state. Note that when you type an expression in the Python shell, Python evaluates the expression and you get a value in return. On the other hand, if you type an assignment statement, nothing is returned. Assignment statements do not return a value. Try, for example, typing x equals 100 plus 50. Python adds 100 to 50, gets the value 150, and binds x to 150. However, we only see the prompt after Python does the assignment. We don't see the change in state until we inspect the value of x by invoking x. What we have learned so far can be summarized as using the Python interpreter to manipulate values of some primitive data types such as integers, real numbers, and character strings by evaluating expressions that involve built-in operators on these types. Assignment statements let us name the values that appear in expressions, while what we have learned so far allows us to do some computations conveniently. They are limited in their generality and reusability. So just to summarize that, we have expressions and assignments. So an expression denotes value. Okay. So we can mark this section as complete. And let's head back to introduction. So we already touched on this a little bit about the naming conventions, but let's have a read through this. So Python has its own set of reserved words that in general should not be chosen as variable names. As we dive deeper into the course, it will become clearer how to apply these reserved words. For now, just be aware that your variable name choices should avoid the words on this list. Otherwise, though, you can choose any variable name you like. It is important to think about how the variable name should be chosen in practical applications. To help others understand your work, you should choose variable names that fit their applications. For example, account balance equals might reflect the balance contained in a bank account. You will build the skill of sensibly choosing variable names naturally as you work through more programming examples. So we can quickly have a look at the reserved words. So we know how to assign values to variables. We know that our variables should have descriptive names. And we also know how to basically, let me just see here. We also know how to compute new variables using variables and operators like multiplication, addition, and remember, like in this example, Python has an order of operations, so it will do the exponents first and the pluses last. We're also going to learn how to use the built-in function type to verify the data type of the value assigned to a variable. So this is not something we covered in learnpython.org. So it's a built-in function called type. So let's take a deeper look at naming conventions. We can use any set of letters, numbers, and underscores to make variable names. However, a variable name cannot begin with a number. There are many different kinds of naming conventions, and we refer to the style guide for Python code that is called Repl.it for a summary. In this book, we use lowercase with underscores variable names and single lowercase letter variable names such as x. It is good practice to use descriptive variable names to make your code more readable for other people. For example, the distance from Vancouver to Halifax along the Trans-Canada Highway is approximately 5,799 kilometers. We write the following code to convert this value to miles. So we've got our distance, kilometers, miles per kilometer, and then we basically do a calculation here to create a variable called distance miles, and we're using the two variables we created here. And you can see how using descriptive names instead of X and Y, it definitely helps to make the code more readable. It is good practice to use variable names which describe the value assigned to it. However, there are words that we should not use as variable names, because these words already have special meaning in Python. So this is a summary of the reserved words in Python. Python will raise an error if you try to assign a value to any of these keywords. So you must avoid these as variable names. So they are false, class, finally, is, return, none, continue, for, lambda, try, true, def, from, non-local, while, and del or del, global, not, with, as, aleph, if, or, yield, assert, else, import, pass, break, except, in, raise. Basically, we've actually covered a lot of these already, so we know how to use these. Built-in function names. There are several functions which are included in the standard Python library. Do not use the names of these functions as variable names. Otherwise, the reference to the built-in function will be lost. For example, do not use sum, min, max, list, or sorted as a variable name. So those are functions in the standard Python library. So we can mark that as completed. .5 Basic Python outputs using the print function. So we've already done this quite a bit in our live streams during learnpython.org. Let's do this as revision. So the print function is a Python instruction that will output variable values and results to the computer screen. This instruction will allow us to automatically output data results to the screen when running a program. This section reviews what we've covered so far and introduces examples of the print function. Try executing these instructions in the command line window to make sure you understand how to use the print function. So let's go over here and we can say x equals 5, 6. And then all we do is we say print, and then in brackets we put the name of our variable. So in this case, x, and it will print 5.6. Notice how the print function outputs the value of the variable z to the screen. It is possible to use the print command in a slightly more sophisticated way. Type this set of commands in the command window. So we have temperature, and then we've assigned it a value of 40, and then we're basically going to print a string. So let's try that. So let's say temperature equals 40, and we're going to print, and I'm going to use double quotation marks because we've learned that's the best way to avoid problems in our code. The temperature outside equals, and then we're going to put a comma and temperature, and don't forget to close our brackets. And that's what it's done. It said temperature outside equals 40. Observe, it is possible to dress up the screen output by adding some extra descriptive text. We will see more examples of this later on as we introduce and develop expertise with the string data type. But as a preview of using the print function with text, try typing this command. So we're going to print hello Bitcoin faculty. Enter, and it prints hello Bitcoin faculty. Congratulations! You have now executed what is probably the most used example in just about every introductory programming course. Read this page to see more examples of using the print function. Try typing some of those examples in the IDE to be sure you are comfortable with the print function. Consider executing these instructions one after the other, that is, sequentially. So we can do that. The question is, what value will the variable var1 contain after these instructions are executed? You can check your answer by using the print function. So obviously it's changing, so it's not fixed. So we can say var1 5, and then we can say print var1. Remember, we use round brackets. So now if we change var1 to negative 35 and we say print var1, it will print negative 35. In other words, the value has changed. So let's have a look at the notes. And we've done these examples. Variables. Any Python interpreter can be used as a calculator. So for example, we have 3 plus 5 times 4. Our output is 23. This is great, but not very interesting. To do anything useful with data, we need to assign its value to a variable. In Python, we can assign a value to a variable using the equal sign. For example, to assign 60 to a variable weight kg, we would execute weight kg equals 60. From now on, whenever we use weight kg, Python will substitute the value we assigned to it. In layman's terms, a variable is a name for a value. In Python, variable names can include letters, digits, and underscores. It cannot start with a digit, and they are case sensitive. So this is repetition. That's fine. That's how we're going to remember. This means, for example, that weight 0 is valid. 0 weight is not, because it starts with a digit. And also weight and weight, so the one starts with a capital letter, the one doesn't, are different variables. So types of data. Python knows various types of data. 3 common ones, and we've dealt with them all, are integer numbers, floating point numbers, and strings. In the example above, variable weight kg has an integer value of 60. To create a variable with a floating point value, we can execute weight kg equals 60.0. So remember, although it's the same number, effectively, they are different type of number according to Python. And in this example, the value that we've assigned to the variable weight kg text is a string. To display the value of a variable to the screen in Python, we can use the print function. Yep, we did that. We can display multiple things at once using only one print command. That's right, so we can just separate it with a comma. So if I say x equals hello, I can now say print and in brackets var1 and x, and now it will print -35 and hello. Moreover, we can do arithmetic with variables right inside the print function. I didn't know that. So in this example, we say 2.2 times weight kg, which is a variable, and weight kg is a number. The above command, however, did not change the value of weight kg. So note, because we're only printing it, we're not actually assigning it a new value. Because remember, the way we assign values to variables is with equals, with the equals operator. So there's no equals operator here. Okay, we're just printing a string. So it doesn't change the value of weight kg. To change the value of the weights kg variable, we have to assign weight kg a new value using the equals sign. Variables as sticky notes. A variable is analogous to a sticky note with a name written on it. Assigning a value to a variable is like putting that sticky note on a particular value. This means that assigning a value to one variable does not change values of other variables. For example, let's store the subject's weight in pounds in its own variable. So there are 2.2 pounds per kilogram, so weight LB equals 2.2 times weight kg. So what we're learning from this, we can include calculations in strings. We can even include calculations in assigning values to variables. So we have finished this one. Let me mark it as complete. And let's go back. Okay, so now we are going to look at strings. And then we are done with Unit 1. Yeah, cool. So strings. Our introduction would not be complete without discussing how to work with text and character data. Characters as in letters. In this section, you will learn about the string data type and assigning a variable of type str, which is basically a string. String data is text or character data. To assign a variable of type string, the text string must be placed in quotes. So that's what we did here in this example with hello Bitcoin faculty. Or even here where we made x hello. To see that this variable assignment has taken place, type the command and then you just print it. And you should see the text string echo to the screen. To assign a variable of type string, you can either use single or double quotes, but single quotes are often the convention of choice. Oh, goodness. As we dive deeper into the course, many interesting operations and computations using the string data type will be presented. Read this page to learn more about the string variable type. Use the IDE to practice some of the string commands. So, I was going to use mainly double quotations, but it looks like the convention is to use single quotations for strings. So a string is a sequence of characters. We can store it and associate a name or variable with it. To strings like hi or broom, we refer to as a string literal in a Python program. I'm just going to zoom out here. Oh, that's interesting. I was actually wondering because it makes sense when you're working with numbers, be it integer or floating points, you have your variable and you'll have your value, like a number is a value. But to define a string as a value, yeah, it didn't really make sense. So what we call it, instead of a value, in the case of a string, is a string literal. String literal. What can I do with strings in Python? Okay, we're mixing up our numbers here. This looks like indexing to me. So when we index, we basically take each character and we number them. And we always start numbering them from 0. So first part 2 would be B. No, 0, 1, 2. It would be R. Correct. Second part 0 would be K. Second part 2, 0, 1, 2 would be D. So notice here that we are using square brackets. So it looks to me like when we want to print an index of a string literal, we use square brackets and then we put in whatever the index number is that we're looking for, keeping in mind that we are counting from 0. And then here, this is called when we split a string. So basically, we learned that, I wonder if they're going to explain it. Doesn't look like it. So here, we have a start, a stop, and a step. So if you watch my screen, I'm going to zoom in. This is a start, and it's inclusive. This would either be a stop or a step, but since there's nothing here, what it's going to do is it's going to, from index 2, it is going to print every character up until the end of that string because we haven't specified where to stop. But remember, the start is inclusive, so it will include the index 2. So if it goes 0, 1, 2, it's going to print Dabra. In this example, we are saying start at 1 and stop at 4. Now, when we stop, for or the index for is exclusive, so we're not going to include for. So on second part, let's find 1. So 0, 1. So it would be A, D, A. We don't include 4. Okay, so A, D, A. We can also concatenate strings like they have done so here. So first part plus second part. So we concatenate strings by using the plus sign. So abracadabra. And notice there's no space. We can also determine the length or the number of characters. So it's 1, 2, 3, 4. We're not indexing, we're counting the number of characters. So it's 4. And then we can also say first part plus, and we can add another string to it. Again, notice there's no space. If you wanted a space, the way you would type cloud is you would put a space and then cloud. You see here, we could have inserted a space there, but in this example, they're putting a forward slash. And then I see how we can also say first part times 3. So it's abra, abra, abra. No spaces in between. Or we can just print the first part, which is abra. Program output commonly includes the value of variables as a part of the text. For the following code, num equals 18, tum equals 9.8. Print, I have a number, so that's all in a string. Then we put a comma, num, comma, string, and a number, comma, tum. So that will basically produce, I have a number 18 and a number 9.8. Note that we should keep track of those double quotes and commas in the print statement. So this method here, formatting strings, is much simpler. Basically, we use %d to serve as the placeholder for number in this case, and %f to serve as the placeholder for tum, which is basically a floating point number because of the decimal. So now instead of having 2 sections of strings and all these commas which are confusing, we have one string, and then basically what we do is by using the percentage sign, we create a tuple. And that tuple is basically the placeholders. So %d is num, %f is tum. So we can try that. So num equals 15, tum equals 9.8, and we can say print, I have a number %d and a number %f, and then don't forget our percentage sign and then our tuple. So num tum, enter. Num tum. Didn't work. Unsupported operand type. None type and tuple. Well, that didn't work. It's my syntax. Very important. It's actually not the first time I've done this. Remember, whatever you print goes inside brackets. Okay. So now we say I have a number, percentage D, and a number, percentage F. This must all be within brackets. Okay. Tum and num. So now shipper detected at line 1. Unterminated string lateral. Oh, print. Okay, let's use both our brackets. Sum both our quotation marks. I have a number, percentage, and a number, percentage F. Okay. Then we say percentage, num, tum in brackets. Yeah. I have a number 15 and a number 9. I'm just taking my jacket off. It's getting hot now. Also notice how when we use percentage F in this example, it keeps on printing zeros. You see, even here. So there is a way around that, although I don't recall. We'll probably get to that. A string formatting expression allows a programmer to create a string with placeholders that are replaced by the value of the variables. So the placeholders are basically these two. And they stay the same. Percentage D is for decimals. Percentage S is for floating point numbers, F. And percentage S is for string. So you can insert a string within a string. A string formatting, okay, yeah. Such a placeholder is called a conversion specifier. Different conversion specifiers are used to perform a conversion of the given variable value to a different type when creating a string. So there's another example. The integer part is 5, so it will probably only, yeah. So in this case where we have floating point number, it's only going to give us a decimal number. So remember percentage D, percentage F. If you want the 5,5, you need to say percentage F. Consider the following code fragment. Price equals 190. So remember this is a comment where you have a hashtag or hash, okay? It's just a comment, so it's not actually read into the code. Then we have discount equals 30. Now we want to print a $% D jacket at percentage D, and then we have 2 percentages. Discount is now priced at percentage F. Now we have price, okay, which is our first placeholder over here, percentage D. So that's the price of the jacket here, which is this variable price. Discount is this variable here, 30. I don't understand why there's 2 percentages. And then to get the price after the discount, we basically said within the tuple price times 0.7. Will basically give us the output. A $119 jacket at 30% discount is now priced at 83.3. So it's actually done the calculation for us. Now we can also consider the following code fragment. So we have two variables, name 1 and name 2. We have Chris and John. And we want to print Chris and John. Now we know the first one is Chris because here our placeholder is name 1 and our second placeholder is name 2. Are heading to the movies tonight. Done. So let's head over. So we've basically been introduced to strings. Now let's look at the type function. So we know about 3 types. There's numbers and strings, but within numbers, there actually aren't numbers. There's just integers and floating point numbers. So the type function is an instruction that can tell us the type of a variable after it has been assigned a value. We can practice using this instruction and the print function as we study data types in this section. Try typing these instructions in the command line below. So we're going to say, let's say x equals 5. We're going to say print x, and then we want the console to tell us what type x is. And it's telling us that it's an integer. Remember, everything we print is in brackets, so that's why I even put type in brackets. If we change x to 5.5 and we say print type x, we'll get float. If we say x is equal to hello and we say print type x, we'll get string. I'm just trying to see what they're saying here. How am I supposed to say this? Repl.it. In the Repl.it script run window, as the number of instructions begins to increase, it can be difficult to type them one by one in the command line. The remedy for this issue is to run several commands at once in what is known as a Python script. The middle window in Repl.it makes this possible. Try copying the above set of commands and pasting them into the middle window beginning at line 1. If you have done this correctly, you should see words that the Python language recognizes, such as print and true in blue. Now press the Run button. You should see the expected screen output appear in the rightmost command window. So we can try that. X equals 5. Print type x. You see how it's even made it easier. Oh, I need to run. run. Yeah, so it's telling me it's an integer. So actually we should be working here. Just for starters, we're working there. So we need to predict the output of the type of function for each of these variable assignments. Well, this one we know is scientific notation, and it's negative, meaning our decimal is going to move 12 places to the left. This one's a string and that one's an integer. So let's try print, print type, and let's try 3.214e negative 12. We run. It gives us a floating number because it's going to be a decimal. I know what these are going to do. This is relatively straightforward. Okay, now we're going to look at some examples of using the print and type functions. A value is one of the basic things a program works with, like a letter or a number. These values belong to different types. 2 is an integer, and hello world is a string. So called because it contains a string of letters. You and the interpreter can identify strings because they are enclosed in quotation marks. If you are not sure what type a value has, the interpreter can tell you. So you just say type. Not surprisingly, string belongs to the type string, and the integers belong to the type int. Less obviously, numbers with a decimal point belong to a type called float, because these numbers are represented in a format called floating points. What about values like 17, where that's in quotation mark, and 3.2, also in quotation mark? They look like numbers, but they are in quotation marks like strings. That means they're strings. When you type a large integer, you might be tempted to use commas between groups of 3 digits, as in for a million, we would say 1,000,000,000. This is not a legal integer in Python, but it is legal. Yeah, it looks like we're creating 3 separate values or elements. Well, that's not what we expected at all. Python interprets 1,000,000,000 as a comma-separated sequence of integers. So now, yeah, it becomes 3 integers when it was intended to be 1. This is the first example we have seen of a semantic error. The code runs without producing an error message, but it doesn't do the right thing. So we are done. is a study session video review. This video, though, might I add, is an hour long. I was already, along with those of you that have attended the live classes in the playlist section, this was revision for us. But let's do the assessment. We'll come back, and then obviously if you're struggling or anything like that, it's probably a good idea to watch the video. But you guys are also welcome to ask any questions in the comments, and yeah, I'll be happy to also assist you where possible. And that's it. We are one unit closer to getting certified. So I will definitely let you guys know how the assessment goes. It does not count towards the grade, but if you are watching this video now, we can pause and do the assessment and then carry on. I'll see you guys in the next video. Thank you for watching. Bye.